Welcome to another episode of Don't Panic Geocacher. My name is Aryan and I go by WhatEvent5 geocaching.com website. And I'm here to tell you more about how to solve puzzle caches, mystery caches, or in this case, field puzzles related to mystery caches. This episode is inspired by a phone a friend. Somebody asked me for help because they were at a field puzzle in Europe and they needed help opening it because they couldn't figure out how to open the lock. So I'm going to show you a couple of techniques that will work for field puzzles where you maybe have to solve something, but also will work for just solving regular mystery caches because all of the techniques that I'm describing here is uh, common techniques used for mystery caches. I'm not using the exact puzzle as it was given, but it is inspired by the field puzzle. And I'm also going to show you how the same puzzle can actually give different answers based on kind of like the clue or information that's being given. So you may want to see what you want to look out for if you're looking for a particular clue on the cache page or sometimes on the cache container. So with that, let's get started. Let's take a look at the puzzle and see how many different ways we can solve it. So when they contacted me, they sent me a puzzle, a picture of the puzzle, and I was like, oh, there's many different options. We may have to look for some clues. But um, immediately the clue wasn't quite visible, at least not to me, and so we had to try different combinations. I'm going to guide you through some of the combinations that we tried, and as you will see, there is easily over 10 and probably close to 20 different combinations that we can try just with very simple. Let's take a look. This was somewhat what was shown. It was slightly different, but also it wasn't fruits, it was something else. But again, very commonly recognized. And the goal, of course, was in this case to unlock a lock. Lock had four digits, so from 0 to 9, and so we know we have to get 4 digits. We have 4 objects, so every object goes to a single digit. Most logical assumption here. So this could, of course, be for a puzzle as well. For a puzzle, it could be the part of the coordinates that you have to do, where you get for each object number. Now, for a cache owner, it might be very obvious what you have to do, but I'm going to show you that without hints, there's lots of combinations that this will lead. So let's go through some of the more trivial ones. So we have these words: coconut, banana, raspberry, and orange. And of course, if it's in a different language, then different words. But for English, this is the scenario. And so we could say, well, maybe it's the length of the word. So number of letters. So in this case, that would be 7, 6, 9, 6. And if you're lucky, it opens the lock. But there's lots of other ways. Because what if we just use the first letter? So C is 3 in the alphabet, B is 2, and this assumes that A is 1, right? A could also be 0 technically, but if A is 1, then it would be 3, 2, and then 18, 15. Well, that doesn't work for a combination lock with 4 because we need to go to a single number. So we could, for example, assume here that we only care about the last digit. So we drop the 1, so we get 3, 2, 8, 5. And maybe that opens the lock. Very common scenario also could be that we have to take something like the word value or take the digital root of value. And I'm going to explain to you how this works. This is a quite popular technique in a lot of puzzles worldwide, that if the answer is a word, that you just assume take the digital root. They don't even tell you, they just assume that you know that that is what you need to do. So if we have those words or the local variant, then what we have to do is as follows. We assume A is 1, right? And so that means coconut would be 3, 15 for the O, 3 for the C again, 15 for the O, and we add all those numbers, they add up to 91. That's not a single digit, so how you get the digital root is you take the individual values, so 9 and 1, you add them together, you get 10. Still not a single digit, so you do it again, 1 plus 0, 10, right? And you do that for all the words. So this is banana, 2, 1, so B, A, N, A, N, A. So sum together is 33. 3 plus 3 is 6. That's a single digit, so we're good. And the same with, for example, raspberry, that in this case goes to 122. So we add 1 plus 2 is 2, right? And we get 5. And so now we have a code that is 1656. And especially if you go to more of like the European areas, this has a very high chance of unlocking the container. Not this container, however. So we had to try more. So what if we just use the first letter? So we have the C, B, the R, and the O. So that would be the C was 3, the B was 2, but now instead of using 8, R is the 18th letter of the alphabet, um, we add the 1 plus 8, and now we get a 9, and the 1 plus 5, and now it adds a 6. This is in the US most likely the common scenario that you would find in puzzles, but also in field puzzles, that you only have to use the slightly simpler, slightly easier, but you still have to know what a digital root is, otherwise you don't get to a conclusion. Going on. This case, hopefully there was a hint, and this happened to be actually the answer to this puzzle. Because what they had done is they had put all the pictures on a wooden tile. And initially in the picture I hadn't quite noticed that because it kind of blended in. But once you realize that they were kind of like big Scrabble tiles, then that was a clue that you had to take the picture, have the Scrabble tile value, and do the calculations. So of course you can do it in two ways again. Only the first letter, so C in US Scrabble is 3, B in US Scrabble is 3, R is 1, O is 1. Again, regional values of Scrabble may change. So in this case, we actually had to do something extra because we had to look at the local version of their Scrabble and see what the letters were worth in case they were any different. In this case, they didn't turn out to be different. Of course, the words were in the local language. That was obvious. We had to do it for the whole word, however. So instead of doing it for a 1, we had to calculate the entire value. So coconut is basically the value of all the letters C, O, C, O, N, U, T. In Scrabble, without bonuses, would be 11. Banana would be 8. Raspberry would be 16. And orange would be 7 for all the individual letters. And now take the digital root. 1 plus 1 is 2. 1 plus 6 is 7. We get 2877. And that was the technique to open this cache. So you see there's already quite a few combinations and there's still lots more options to try. Because, again, maybe more in the US, phones often have letters. And it was quite popular to utilize to spell out a phone number using letters. So 1-800 get help would then get help GET3438, right? We can do the same thing with the word coconut. So the C would be the 2, the O would be the 6. And again, if we only use the first letters, then we get 2, 2. R is on the 7 and the O is on the 6. So we get 2276. Or again, we can do the full word and calculate all the individual letters where they fall, take the digital root, and now use that as the code. So that's yet another technique. I didn't work out the full one, I just showed that it was an alternative. So I think we're over 10 options yet, and done yet. Still more options to try. Because we can also look at keyboards. So keyboards, of course, have numbers. Keyboards also have letters, and they sort of line up. So if you look at these diagonally, then you see this is kind of like 1, 2, 3, 4. That's the position where they are, right? Because this is the first letter, this is the second letter on the row, third letter on the row, fourth letter on the row, fifth on the row, sixth, seventh. So they nicely line up, and we even get all the way to the 0, so nicely all letters are mapped. So this is of course a US keyboard, so international keyboards might be different, but it gives us again two alternatives of how to encode just by the first letter. So C being on the third row, the B being on the fifth row, the R being the fourth, and the O being on the ninth. 3, 5, 4, 9, and we can see if that opens the lock. Or again, we can take the entire word value and do the same thing, right? So instead of just using it, looking at C, we can see the O is now 9, C again it's 3. Add all the letters, take the digital, get to another number. Again, I didn't work that out, but so every time you see me use the first letter, you can assume you can do it with the whole word as well. Gives you another combination. The keyboard actually has two scenarios because I looked at the position on the row, right? The first letter, second. But technically, you could see these are diagonals. I can also look at them the other way around. So now the Q would match to 2, and the W and the A would match to 3. The disadvantage is that nothing maps to 1, and the P and L don't have a mapping. So this would be quite hard to guess that this was the technique, but it is certainly possible that we do it through the right. So now certainly with the first letter, the C maps to the 6, so we see it this way. The B maps to the 8, the R matches to the 5, and the O matches to the 0. So 6, 8, 5, 0. Again, Raspberry, for example, wouldn't be able to encode in here, but that could be a trick as well because it goes to the minus sign. So maybe RAS, R would be 5, 3, and the S, that would be 12, and then minus berry. Well, in this case, it wouldn't work because the berry is all high letters. So the B goes to 8, Y, so it would be a negative number. But there might be words where this would actually give a valid equation. And so you would maybe have to solve the equation or maybe the digital roots. So this could definitely be a high puzzle. Probably slightly too difficult puzzle, but yeah, possible. So now we have keyboards. Um, this made me think that there was actually another solution to this, and one that, again, for a field puzzle might be slightly tricky, but it could be also be chemical elements because all these fruits start with a abbreviation of a chemical element. So if we look at CO, that's cobalt. Cobalt is 27. Take the digital root, would be 9. Ba, barium, be 56. Digital root is 11 or 2 at the end. Right, the sum is 11 and 2. Note that B is also a chemical element. So in this case, maybe the nice hint would be to underline them on the page. And that way kind of give a clue that you have to look at an abbreviation. And that would now be. Now in the US, it could also be states, but not all of these are states. CO would be Colorado, but the other ones you get quickly. OR is Oregon, but the other ones don't have clear way to translate, so that wouldn't work for all four. But maybe with different fruits, they could be US states. And now state numbers are very common to use. So you see lots of different ways, and so unless there was a hint on the page, it would actually be quite hard to figure out how to do this. And there would be lots of things to try, and you might stand at a field puzzle for a while, trying combination, doing all the math that you have to. Fortunately, there are some tools that can help you. So these are two tools, and I'm going to show how they work and how they can make it easier for you so that you don't have to do all the calculations manually, but also kind of remind you of the things to try. Let's take a look at those. So here are the two tools. I will start with Geocaching Toolbox, and it has an option here, word value or digital root. And if we go there, we can enter our words. Note that by default, it will count all of them together. So we have to say count separate words. And now we get the values. So you see here the values of the first letters, 3, 2, 18, and 15, which of course we can take the digital root, just those, or it will calculate the whole one as we see here, the 1656, because with the values 90, 30, 120, and 60 brought back to a digital root. That saves you having to manually count those. So I have my own variant of that. So we put in the different words. By default, it will take each word individually, and it will do all the different combinations that we just talked about, other than the length, the word length. It doesn't calculate those. But it will do the phone number and basically say where all these letters are on the phone, and then calculate the sum, and then tell you the digital root. So 3 plus 8 is 11, 11 is 1 plus 1 is 2. And it does it the same for keyboard mapping in both directions. The alphabet starting at A is 1, um, alphabet, but just taking the last digit. And also the alphabet code, which starting with A is 0, as that sometimes is used as well. So that's another combination. And then the Scrabble value as, and then taking the digital root of those as well. So it calculates all of those so that you don't have to calculate them individually. It gives you a lot of options and you can pick and try them one by one until you have the one that you're looking for. So yeah, so those are two tools that might help you in the field, or at least even remind you of what things to try when you get a puzzle like this. So that's the end of this episode. Hope you enjoyed it. Hope you learned something new, saw something new, got to see maybe some new tools as well that can help you solve things faster. Please like and subscribe. That way I know that you enjoyed the video, but also that way you will stay informed when new videos will drop. In the meantime, if you want to contact me, as usual, you can contact me on the geocaching.com website by word of 5. You can also email me at if you have attachments or something else at geocache.wordofn5@gmail.com. With that, thank you very much for your time and good luck solving more puzzles.